All right, so let's get started, and happy to see so many people already joining. So welcome to this week's of PTC Talks, where I'm a bit extra excited today by having Sofía from Volvo Group and Paulo from Chalmers University of Technology for a session on enhancing traceability in manufacturing supply chains aided by digital platforms. And the reason why I find this session extra interesting is that it's about a research project where I've been partly also engaged myself. But let's start with a very quick introduction by me. My name is Torbjörn Pilsson, and I'm the Alliance Manager for PTC, leading these weekly webinars where we invite customers and partners for some inspiration on digital transformation to see what is possible and how to make things happen. And we are running all those webinars on Fridays, same time, topics around either manufacturing, services, or engineering. And the recordings of all the past sessions have been to be found on the registration side. And the agenda for today is first a quick overview of PTC by myself, and then Sofía and Paulo will run the show, but they will also touch base on a few challenges, how to address these, and then to explain some of the business outcomes. And at the end, we're also having a Q&A session, so please keep your questions to the end, or you may also put them in the chat, and we will pick them up during the Q&A. Next slide, please, Sofía. So just a very quick overview about PTC for those who don't know us still, and we are a global software company headed in Boston, and we provide market-leading solutions on IoT, augmented reality, PLM, CAD, SLM, and ALM through the digital thread to help companies to accelerate the digital transformation. Now over to you, Paulo.
Well, thank you, Torbjörn. Can you listen to me? Yeah, right. So this whole initiative started in a research project called Digital Stambanam. And as a good research project, we start with a purpose. And our purpose was since the beginning to improve digitalization to achieve efficient and effective industrial activity. Please, next. Our way of working in this sense is collaboration, data integration, data insights, smart documentation, knowledge management, to achieve improved way of working, focusing mainly on data transference, and how to process this data to achieve good results. Please, next slide. So this Digital Stambanam project is a project with three main supply chains. We are working mainly on the second supply chain, and it is included on Sansera, Volvo Hovde, and Volvo Penta as a supply chain, but also we count on different partners as PTC, Microsoft, KPMG, HMS, Chain Traced, and Peer. Please, next slide. So in our supply chain 2, that is specifically the one we are sharing results today, we started trying to understand how to demonstrate the potential of platforms to digitalize value chains. Focused on traceability, quality assurance, reducing time and efforts to trace back information, and data exchange in scale. So this started, thank you. So when we talk about traceability and quality assurance, how they are related. In a supply chain level, the material flow starts from the beginning to the end. So in our case, we had con rods and engine blocks, and finally, a dealer of the engines. The material flow is easy to track, to follow, but how to trace back this information is a challenge that traceability address and requires substantial efforts to trace back this information because of variety of different IT systems, variety of places where this data can be stored, and then this becomes a challenge in the practical situation. In order to understand more about how, in practice, this traceability process is perceived inside the value chain with our partners, we ran some interviews And in the next slide, we understand that this theoretical scenario that we talk about, oh, it's hard to trace back information, how we can trace back this information, was also perceived by the practical partners. And from our interviews, what they have to say about root cause analysis process, that is the process of tracing back information to understand how disturbances or variations happens in the production process. So they highlighted four main aspects of this root cause analysis process. First, recurrence of production disturbance. So there are some specific production disturbance that can be recurrent, and it takes a substantial amount of resources to find the root cause for these specific situations. And when the root cause analysis process is performed, the visualization of this information could be improved. And often it's hard to get the conditions and the right conditions and competences in place. So this was our main scenario. And when we talk about technical background for that, what's the technical background that can be the one that is triggering this situation, this challenge to trace back information? So we mapped the ICT systems and ICT infrastructure inside the supply chain, and we understood that inside each one of the companies, the data exchange can even be okay. But when we talk about exchanging this information between different companies, this can become a bottleneck, because the email communication, as we can see here, between company 3 and company 2 communication, the email communication can still be used. And this constrains a lot our perspective on how we can process big data, how we can process data in scale, apply AI algorithms, and enhance this procedure for root cause analysis, and also tracing back information. So next one, please. So I talked a lot, and in practice, how does the root cause analysis process work? We have a paradigm, the traditional paradigm, that is how it works. The pipeline model to trace back information. So not fully connected systems require a lot of interactions between different partners. For example, if one issue is detected on quality in company 3, they need to request data from company 2 quality team, and then company 2 quality team needs to request data from the production engineers, and then the production engineer needs to start manual data collection from different sources, and then they can provide this data to company 3 quality team. Next slide, please. So when we change this paradigm to platforms, the users can directly access the data from the platform, which reduce a lot the number of interactions, making this process of traceability more efficient. So here we have one example for that. And next slide. So in an animation, how this looks like? Yeah, this looks like this image here that is from Adriana Ito, was working in our project previously. So when we imagine how a collaborative digital platform can work, the data exchange is much easier when you have a centralized platform. So the users can access that platform. And in the next slide, I can talk about what's the background about this. We see that we have a line and then we have a curve. This line is in the pipeline models. When one person needs to connect other person, you have the cost of each interaction continue, but the benefit and the benefit also. But when we have a platform, you may have costs in the beginning, so you have low profits. But when the platform starts to be used, more users can interact with the platform without the same time investment, which means that we have a profit or a value that is increasing exponentially compared with the value that is being increased linearly in the pipeline model. And this is, please, next slide. Not just something that is happening inside our project and inside our value chain. In Architect Maturity Index assessment made with 70 companies in Germany, they realized that at least 80% of this industry are inside the maturity index in digitalization level 2, which means that systems are connected, but this visualization of data is still constrained. So what are the consequences of that? The whole industry, or we can say that a majority part of industry is nowadays concerned about how they can make the visualization of data more efficient. And now I hand it to Sofía to talk about how we are handling that inside our supply chain and how platforms can enhance these interactions from a practical perspective, besides the theoretical background.
Thanks, Paulo. And I'm going to start from this figure that we see here from the Industry 4.0. While this is mostly used for measuring maturity index, in Volvo we also took it as a way of working because it really indicates the different steps that we can take in a data science project. And it has really helped us understand what are the different things that we need to secure in order to go for more advanced solutions every time. So I want to start taking a look at this and how we have adapted in Volvo to our ways of working in operations. The first thing that we've added to this is pretty much the same thing. We just added this cultural incompetence below, because for this to happen, it's very important that people are also aware of what the different stages imply, how to access the different data sources, and also to be able to mix that with their expertise from their different domains. So that's something that is very important for us as a manufacturing company. So if we look at the first step in Industry 4.0, we say that visibility, our take on what it is in a data science project is to be able to see the data and understand what is happening. So in manufacturing, we do something that is called Gemba, and is that whenever we want to understand the problem, it's not enough with just getting a description of the problem. We have to go to the Gemba, which is the place where things take place. And then what we do is that we go to the line and we visit it, we talk to different people, we see how the process is going on. And then what we propose to do when we go into it from a digitalization complementation as well, is that we also take a look at a digital Gemba. So while we're going through the process and we're looking at the different machines, doing whatever they're doing, we're looking at the problem, we're talking to people, we're also trying to understand how is that problem being reflected on the data that we're collecting. So what are the sensors that we have available? What additional information could we have that maybe we're not mapping today? If we're mapping information, how does it look like? So we collect samples and then we try to understand that data. And that can secure what we need to go into the next step, which is transparency. So when we go into transparency, we pass from asking ourselves what is happening to why is it happening? And here is when we would do root cause analysis, but with data, we can do root cause analysis as well. So in this case, what we would usually do would be to say, okay, we have our set of data, but how is this being correlated to whatever is happening in the line and to whatever problem we're trying to analyze? So we would take different features and then we would analyze the correlation of those features to whatever result we're looking for. And then we would mix that up with the expert's view as well. So we would talk about that with the manufacturing engineers or with the qualitatians and try to make sense to those like relevant correlations that we're getting out of our analysis. So that would allow us to get the most important features of all the data that we're looking at. And those important features then we can collect in an easier way to make sure that they're clean, that they're well prepared, and that they constitute a data set to then go into the next step, which is predictive capacity. So for us, it would be predictive analytics. So then in that step, what we do concretely is that we collect those relevant features, as I said before, in a clean way. Then we train an algorithm, we test it, and then we build up a pipeline and we deploy it. And then we will be able to know what will happen, but only for that specific case. And then the next step, the final step, would be to go into adaptability. And what we do in that sense is that instead of only focusing on that resource, we expand and we look at the influence of the problem that we were looking at, but for the whole flow, and we try to adapt to it. So in that case, it's how should we respond, but in a more general way. And then for that step, we will collect much more contextual information. And again, we will train and test algorithms, and then we will build a pipeline to make those algorithms work with live data, and then we will deploy it. So I just described this in a couple of minutes, but concretely speaking, whenever we're going to start a project, to just ensure visibility, to go outside, talk to people, get the access to the different data sources, with all the challenges that Paulo says that most manufacturing industries we have today, that can take a couple of weeks, maybe a month. Then when we go into transparency and we do the root cause analysis in studies done offline, say that can take up to a month as well. For doing the predictive capacity and have an algorithm that is working online with IoT, with live data, then it's a little bit more complex to completely industrialize it. It can take 6 months up to a year, and we're barely starting to grasp the possibilities that come with adaptability. So that's just to give you a flavor of how it is actually going on in the shop floor for us, and then where we're set up for this use case that Paulo just mentioned. So now I'm going to talk about that one concretely. So we started with the Gemba, right? We went to the plant, we walked around, and we tried to see what was going on. And we saw these issues of the relationships between the OEMs whenever they have issues and they want to trace back data to understand what happened in manufacturing that make the specific products work in a specific way whenever they were delivered to the client. And we found something that was the perfect use case for us, pretty much. That is something that happens in our tests. So basically how how usual tests are designed is that we get a sample. So in this case, we can see it's just a figure that is showing a bunch of engines that are okay. And we're comparing their behavior against this window. That is the threshold that the engineers would set, saying, if our data goes beyond this threshold, then we say that the engine is not okay. And if it is below, then we keep it as an okay engine. And then in this case, well, we get this new engine that we see on top, and we say this engine is not okay. But we say that it's not okay only because it went beyond that threshold on these 2 points, which is not very robust, because as you can see, the whole data is behaving very differently compared to engines that are okay. So this is also something that we're going to do for all of our tests, because usually how things will traditionally be done is that we secure that things are within a threshold, and then we say, okay, we produced it according to whatever specifications we had. But we could do so much more to secure quality with all this rich information that we have from our tests. So what we thought of doing in this project is that, imagine that we receive the engine result, and then we compare it against the threshold. And then in this case, we say, okay, according to the threshold, this engine is okay. But then what we do is that afterwards, we send that data to an AI, and the AI has been trained on all the historical data and knows how usually the engines behave. So running a very simple anomaly detection algorithm, it can say, wait, this one is an anomaly, and then it can store it somewhere. And then in the future, whenever we have engines that fail in our clients' vehicles, then our OEMs, they can look directly at the anomalies database. They can query per engine ID, and they can look if those engines were following specific patterns, and then they can alert us, and then we can say, okay, so from now on, we're going to start looking for these anomalies as well, so we can catch them before we send them to the client. And by doing that, the anomaly detection is just an example of any kind of intelligence that we could put on top of it. But if you think about it, we're going from them seeing a failure on the field and then having to email the people in the plant, and then finding the right person in the plant that can access the database from the test to see if there was any kind of anomaly, to having a database that is simply available for them with some intelligence on top that we build with the expertise from the people from production. So we're really just making the information available, and by doing that, we're reducing a lot the amount of interactions that would need to take place for anything to happen. And just like that, we speed up the process, and we also make sure that potentially we can catch up the quality issues before we release them to the clients by doing this kind of analytics. Yeah, so these are the two opportunities for improvements that we saw. The first one is to be able to make available relevant production data, and then also that if they want to include new data points, if they say in the future, oh, we would also want to consider this other sensor or this other algorithm, it would be also very easy for them and for us to set that in place. So how we're doing that concretely is that we have the machines in production, and then the machines, they are connected to a PLC, they're producing a lot of data, and this is where PTC comes in. So we connect the machines via Kepware to ThingWorx, and then at first, when we're just collecting the data, we extract it manually so we can explore it, so we can see how it looks like, and we can build a model. And then we build a model, all the scripts for pre-processing, automatically training and testing the algorithm. And then whenever that's ready with our samples, then we build a more robust pipeline to be able to make the training and testing automatically. And then we use Red Hat OpenShift to be able to run those algorithms. So ThingWorx connects via an API to Red Hat. And then whether it is for training or testing the algorithm, it will just send the data. Then Red Hat does inference or training based on these scripts, and then it will send the answer back to ThingWorx, and then ThingWorx will do whatever it is, if it is to save the anomaly or just to store the results. And this is a very small demo of it, but this is how our data collection for it looks like. So this is an example from one of our tests in the Hoofde plant. And here you can see that, for example, we're following the oil pressure and oil temperature for an engine. And in this case, both results were normal, but then in this case, one of the results were abnormal, and the test result was actually okay. So this would be one of the cases where we would want to like keep this data, so in the future, our clients can, our OEMs can look at it and say, okay, is this related to any quality issues that we get on the field or anything like that? And then they can also go, oops. They can also go inside and they can look how the trend looked like. They can compare it against other trends. And this is a very simple UI, but it's to reflect that that's the data that we're collecting right now. And it's the data that is now on that platform available for them. So it's a fairly simple solution that really opens up a lot of possibilities for us. Paulo, are you still with us?
Oh, yes.
Yeah, I had some.
Let's go on, Sofia.
Slide already in the screen?
Yeah.
I'm sorry. Can you see my screen?
Oh, yes, we can.
I'm sharing the presentation again.
Okay. So yeah. So in resume, what we did already.
You're breaking up a little bit, Paulo.
Things direct to access this data, and then quality database and apply algorithms and also dashboard.
Still breaking up a little bit, Paulo.
Can you hear me?
Yes, now we can.
Sorry. Yeah. So I will talk slower. outcomes of these traceability data, quality data films, and dashboard.
Still breaking up a little bit, Paulo.
More efficient. You can be free for that.
Right, I think we are coming to the Q&A actually. So thank you, Sofía and Paulo, for sharing a lot of very interesting stuff here from your research project. So now actually, over to some of the questions, to the end here. I think, we could do that. So if you have any questions, please raise your hand and we will open up for questions. I will see in my chat here if you have a few.
There is one from Samora in the Q&A widget.
Let me see here. If you have the question, I will just open up here. Otherwise, I will start with one question before that, and that is about, thinking about the difference between, business products and research products. What would you say are the advantages of, developing these kind of, solutions in a partnership with the academia? Could you elaborate a little bit on that, maybe? From your end, Sofía?
Yes, totally. I think that one of the biggest things is that we get to collaborate with other companies. For example, to have this collaboration with PTC, with some of our suppliers, with other technology providers, that's definitely super interesting. And I would also say that research projects also bring in a lot of flexibility and ability to try new things. We're not necessarily solving to having to deliver a specific result, and we're much more flexible on the things that we can try out.
Right, thanks. And what would you say are the main lessons learned from this integration of these innovative kind of technologies in practice?
I think that, well, from my perspective, is that there are many things that are happening in academia or that even happening that at the proof of concept level that seem pretty simple, and then when you try to take them to an industrial level, you have to take into account so many more things, not just to have it working live, but also to have the culture around, to have the engagement from different people. And that's where the maturity index also comes in as well, that I think is very important. It's not just to have an algorithm that works, it's to have the people maintaining it, to having the whole flow around it that works. I also think that from a digital estamina perspective, it has worked because we have had a lot of trust between the different companies that are part of it. So, for example, to be able to collaborate like this with PTC, I think it has been a huge plus for the project.
Thanks a lot, Sofía. So, in what way do you think that, an increased maturity of digitalization adds value to a company like, Volvo in your case here?
It really depends on the area because Volvo has many fronts. So from an operational perspective, working in manufacturing, I think that it, of course, enables many tools that are linked to Industry 4.0, even Industry 5.0, and that opens up the possibilities to doing many more tests, to sharing much more information within the company, to help people upskill, but also, for example, technologies for doing better quality detection, for doing better traceability. That also allows us to concretely stay in the front and remain competitive.
Thanks. And another quite interesting question. If you would have started this kind of product today, knowing what you know today, is there anything you should have done a little bit differently maybe? Maybe that is a question also to Paulo, but starting with you, Sofía. Would Would you have done it, I mean, exactly the same way, or?
No, I think that one of the main things that pushed the project forward was the visits and the workshops in person. Something very funny is that we had a bunch of meetings that were like 30-minute meetings where we would all try to discuss, but things wouldn't happen. So I think that it was very, very good whenever we had these big workshops where we would just sit down and work together. So I think that I would try to prioritize that.
Right. And elaborate a little bit also, I mean, about, I mean, what are the sort of, I mean, biggest challenges that, I mean, you have been facing, I mean, throughout, I mean, the product from your perspective?
Can you listen to me now?
Yes, sure,
Yes.
Paulo.
Oh, finally. So I can handle this one.
Right, please
Yeah.
go ahead.
So
Right.
some challenges are that we have many competence, but when we deal with this kind of innovation projects, the ecosystems are really important. So sometimes you have competence, but they are in different places, and trying to integrate people and build up more trust and having a strong ecosystem with collaboration and cultural background is really important. For example, Chalmers, PTC, and Volvo are good partners in this sense. We have a lot of previous collaboration, and having this kind of well-structured ecosystem can help a lot when we start a new project in this innovation field.
Thanks a lot, I mean, for the kind words, Paulo.
Mhm.
So time is actually unfortunately running out. So many thanks everyone, I mean, for joining this very, very interesting session. And of course, a very special thanks, I mean, to you, Sofía and Paulo, I mean, for sharing a lot of, I mean, insights and good, very interesting things, I mean, from this specific, I mean, research project here. So with that, I hope to see you back at the next PTC Talks on the 24th of May, on Friday next week, for a session about product footprints, preparing for new CSRD compliance priorities by Dave Duncan, who is our Vice President of Sustainability at PTC. And he has been on a recent 3-month road trip across EMEA, meeting with hundreds of companies, discussing sustainability. So that will be also a very, very interesting session. I'm quite sure about that. So with that, stay tuned for that and have a fantastic and hopefully, I mean, sunny weekend, everyone. Take care.
Thank
Bye-bye.
Thank you. Bye-bye.